My name is Dan Ardelan. I am a Microsoft MVP on developer technologies, former MVP on Windows development and Windows Phone. I co-own a small company in Italy, and today we were going to talk about memory leaks in Xamarin application. It should be called my Xamarin application is leaking memory, the session, not your Xamarin application probably leaking memory. So 2 words about my company. The headquarters are in Italy, and we have local offices in Cochabamba, Bolivia, and Bucharest, Romania. Actually, I've traveled here from Cochabamba, Bolivia. It took like 18 hours. It was a long trip, but I'm really happy to be here and excited. So what we do is software development, consulting, and training. Forgot to mention, I was a Xamarin University certified trainer until it was merged in Microsoft Learn. So when you usually go to a Xamarin presentation and it gets you started, you will always see that it's really, really simple to download and install Visual Studio. Then you write some C# or F# code, press F5, you wait a little bit, and because it's the first compilation, you wait a little bit more. You all know that it takes a little bit longer. But it's normal, because under the hood, there is magic. And when it finishes compiling, boom, you get native iOS and Android application. And they are really native ones. And Xamarin, it's really, really powerful. But with great power comes great responsibility. You'll have to understand a little bit how Xamarin works under the hood in order to master the magic. So we will do a little bit of both, Xamarin iOS and Xamarin Android. And we will see some problems that you'll encounter. And my focus here is to make you aware that it is a native application and what's going behind the hood. So somebody said this is from Spider-Man. Yes, but this is the dark side of Xamarin, so it combines the two of them. So Xamarin iOS. So what you have to understand is that you have a native process, and as Apple does not allow just-in-time compiling, the .NET runtime is ahead of time compiled on the platform. This is why the more platforms you are choosing when you compile, the bigger the package is. So the .NET framework is pre-compiled. The garbage collector works as a service, and it is injected in the native project process. So you have, right here, you can see the native process, so the window, the application, and then the custom objects. The custom objects are objects created by the .NET runtime and gives the possibility to first to receive events from the native process. So it's a bidirectional communication with the native process. So remember, we have a runtime injected in another process. On Android, things are different, because on Android, we can have just-in-time compilation. So in the process of my application, we have 2 runtimes. So we have the Java one, because as you know, every piece of UI in Android is written in Java. So you have the Android runtime art, which has all the Java part. And then in the same process, you have the mono runtime, which manages all the .NET objects, OK? So when it has to create an UI element, what we'll do, it will use a manage callable wrapper and call into Android runtime and create the object. And then it will maintain a proxy object inside the mono runtime, so not the full object. It will maintain that proxy object that communicates, give the possibility to communicate in both directions between mono and art. Okay? So what does it mean? It means, so in this case, you have also the .NET runtime, but also in this case, a lot of the memory, it's in the native one, because it's a native application. So what does it mean from the memory point of view? So you have the process, and then inside the process, you have the native object. So the native objects, for example, these are iOS, UI view, UI image, map view, and these are Android. So these are native objects managed by the native runtime. And then you have the managed memory. So it's the memory that it's managed by the C# runtime, the .NET runtime. And what is important to understand here is that this piece of memory is really small, because all the most objects are native one. So when you have an UI image, for example, what the .NET runtime will see, it's a proxy object that was created to communicate with the native object. So that object is really small, can be around 4K. But on the native side, that image can be 7 megs, can be 20 megabytes. So if you think at garbage collector, you know that the .NET runtime works with garbage collector. And when does the garbage collector start? Automatically, can somebody tell me? When does it start? When does it fire? Memory pressure, actually, we have the first step, which is memory step, which is the nursery. So we have like 16 megabytes, which is the nursery, where you start allocating the objects that you probably think that they will die fast. And then when you fill up that space, you start the garbage collector. So the garbage collector, what it does, it goes to see what objects in the nursery are still alive. And if they're still alive, they move them to another space, so it will clean up in generation 2. And if they can clean up, they clean up. But important to think it's, if you have an image, UI image in the .NET framework, which is 4 kilobytes, and in the native part is 10 megabytes, until you fill up the nursery, you will see a bump in the memory. It's not a problem because the operating system will say, hey, memory pressure, and the memory pressure will launch the garbage collector. So the object in memory will have a proxy object, which is the Xamarin managed one, and a native one, which is the iOS and Android. And they communicate using a binding layer. It's a bidirectional communication. And what the runtime has to do is make sure that if Xamarin needs those objects, those native shouldn't be clean, or if it doesn't need them anymore, they should say to the native mechanism that it can free that memory. So we have actually 3 types of objects. We have full managed objects. So when you allocate memory in the .NET runtime, that memory stays only in the runtime. The iOS doesn't know about that memory or the Android. So this memory is the only one that's fully managed by the .NET runtime. And then you have the peer object. So we will understand what are the peer objects. So we have framework peers and user peers. So if you look into the documentation, you will find them. So we will start with framework peer. So a framework peer is actually an object that exists in both worlds, so in the native one and in the managed one, but doesn't have state in the managed one. What does it mean? If it doesn't have state in the managed one, then I can use a weak delegate. So I won't keep a strong reference to it. So the native one, if it can clean that object, it can clean it. So what you have here, you have an Xamarin UI Kit UI button. Then you have the native one, And when you do this, actually under the hood, because you don't give state to this UI button, doesn't have state in the .NET framework, you will see under the hood that the .NET runtime calls the native method. So it sets the title, and then it uses everything. So the framework peer is an object that exists in the native space, doesn't have state in the managed space, but we call it from the managed space to interact with it. So then we have the framework peer, the user peer. So the user peer are the objects that exist in both worlds, because we have a native one and a managed one, but we give state in the managed space. So for example, if we derive from an UI view, so we derive from UI view, we have the native one in the native space, and we give some state. We give an ID to the footnote or another variable. This means that the foot view should not be freed until the .NET framework says so, because it has to know, and always you have to have the same reference from the runtime to that object. For example, for the framework peers, sometimes, depending on the runtimes, have you seen if you do an action and you have the sender, which is the object that is the sender, sometimes you don't have the same instance for the same control in the native part, because it did not need it. So it will create a proxy object at runtime. So how memory management works in iOS natively? So you allocate an object. It uses automatic reference count, or ARC. So when you allocate an object, you retain it, so you have a count of 1. Then if you reference from another object, you have a retained count of 2. You release it, you release the first object, the release, and the reference goes down to 1. And then if you do the B release, as the retained count reaches 0, it is freed automatically. So it does not work with garbage collection. The memory, as soon as the retained count, nobody has a reference on that object, the memory is considered that you can free that memory. So on the native part, because you have a native object under the hood, it works like this. So what Xamarin iOS does is, you will see it right here. So you can allocate a button. So under the hood, it will call init, and you have a reference count of 1. And you work with it, and then if you can collect it, when you collect it, it's released, and the memory is released. The native memory is released. So you can do this, or very important, you can call dispose. So the big difference between the full .NET runtime and Xamarin is that sometimes, if you call dispose on an object, you break the link between the native object and the managed one, and the memory can be freed. If not, of course, you can wait for the garbage collector that will see if the object can be cleaned. It will clean it, and it will break the connection. So Android. Android is a little bit more complicated, because you have 2 runtimes just in time, and you have 2 garbage collectors. What it means is that these 2 garbage collectors have to work together to understand which objects can they clean or not clean. And also, the runtime has to keep some references to the objects in Java that it doesn't want them to be released. So let's take a very quick look on how the garbage collector process works on Android. So you launch, or it is automatically launch, a garbage collect. So what it sees, the .NET runtime sees, can I collect this object? If I cannot collect it, then it cannot be emptied. So can I collect it? Is this a peer object? So is this object also in the native space? If it's not in the native space, then I can collect it because I'm managing all the memory, right? If it's a peer object, then for sure, in order to block it from the Java garbage collector to free it, the .NET runtime has a strong handle on it. So what it does is, I want to see if Java can clean this object. So I'm going to replace the native handle with the strong handle with a weak handle, force the Android Java garbage collector. So was the Java native invoke collected? If yes, it means that also the Android part was clean. So it's going to clean the .NET part. And if it's not, I'm going to, because it means that the object, the native object, is still referenced in the art runtime, I'm going to replace again the weak handle with a strong handle. So you have, and this process of replacing the handles, it's called the bridge, and there are more than one bridge mechanism. So with Xamarin, where can we have memory leaks? Of course, we can have in the Android SDK and iOS SDK. Nobody's perfect. What can you do about it? Nothing, because you have to wait for a new release. You can have it in the .NET runtime that is injected in the process. And at Microsoft MVP Summit, actually, I found one bug. And what can you do about it? Nothing. You have to wait for another release of the runtime. Or you can have it in your space, in the .NET space. So what means .NET space? It's the code you write, sometimes, usually, hopefully. Then it could be a framework. So just think that Xamarin Forms is in between. So Xamarin Forms can leak. And then you have to fix it. Or another user control that you're using can leak also. So on this part, you can fix it. So as long as it's in this .NET part, you should be able to fix it by rewriting a control, by rewriting your code, or a pull request to Xamarin Forms. So how can you monitor memory allocation? You have the native ones. So with this tool, you can monitor the native allocation. So you have the instruments for Xcode, and you have the Android Profiler on Android. Then you have the Xamarin Profile, which is a nice tool, but costs a lot. And then there are manual methods. And we will see a little bit of all of that. So Xamarin Profiler, what it does, it's a tool that will show you the managed memory. So it will show you the allocation, how many objects, and so on. Also, you can monitor without Xamarin Profiler. You can use, in the debug mode, in the console, you will actually see when garbage collector is happening. And when it is happening, what you can see, this one is for Android. It will see how much the application how much time the application stopped. You know that right now, garbage collector is a stop world. So you have to stop all the threads of the application, move the memory, and make it run again. And this one took 6.53 milliseconds. And if I'm not wrong, somebody said on Android, if it's bigger than 17 milliseconds, you will see it. So on Android, even if you have a really powerful device, if the garbage collector takes a lot of time, you will see it. But this is both Xamarin Android and Android native. You will see it in both. So with this, you will see how much the memory was before the garbage collector and after the garbage collector. So you see that, let's see, before it was loss is large object segment. Before it was 74K, and now it's 0. So this tells me that probably I don't have a memory leak. But if this thing continues to increment, this means that somewhere in my application I have a memory leak. Or you could check for a leak. How can you check for a leak? You can use weak reference. How many of you used weak reference? So a lot of you. So what you do with weak reference is you create a weak reference on an object, then you set that object to null, you collect, and then you check the is alive property to see if that object is still alive. If it's still alive, it means that somebody else is keeping a reference. The rest of the talk, it will be demos. So I have 4 demos. And I will start with the basic one. So the first one is a Xamarin Forms application. Let's see if it loads. So it's a simple application. I have the application has a navigation page with the main page as the root. And then in the main page, I have a button that will navigate to what I call a problem page and a button to do the garbage collector. Okay? And in the problem page, what I do is I'm using the cross-connectivity plugin. I subscribe the connectivity changed event, and I change the background of the window to green or red if I have connectivity or not. And I will run it. And what I do in order to make you see the leak, I use an array of bytes of 20 megabytes. And I allocate 20 megabytes on each instance of the problem page. This way, you will see that the memory increases. And we will do it with the Xamarin Profiler. I'm going to do it on Android. So if you have the Visual Studio Enterprise, you can use it. So you'll see, you'll have the option in the menu. You do start profiling. It will launch the profiler. Actually, first it will launch the Android emulator. It will see if the version has changed or not, deploy to the device the application. Should be pretty fast. And then it starts the profiler. So I will only look at the allocation because I'm interested in the memory leaks. I will do start. I have some options. The option is to automatically enable snapshot. What is a snapshot in Xamarin Profiler? It's a garbage collector followed by saving all the memory state. So it runs the garbage collector and then saves the instances of my application. And I'm going to start profiling. And you will see that as the application runs, okay, you will see the memory that it's using. Here, what is interesting to see in the profiler is that actually in the managed part, we only allocated 506 kilobytes, while the native object in the native runtime are those private bytes, which is 209 megabytes. There are a lot of objects, so it's not really useful to see all of them. Actually, it's pretty scary to see all of them. So what you actually do is do a filter, and the simplest filter that you can use, it's your main namespace. So network state. And it will actually show me how many objects of each type in my main namespace I have in the application. So I will start navigating back and forward. So if you see now, the memory increased by 20 megabytes. Now it's 132. I will run it again, and it's 154. I run it again, and it goes 20 megabytes. And what I will do, I will force a snapshot. So I will force a garbage collector. OK? I force the snapshot. And now that I have a snapshot, one interesting thing, I can go to snapshots, and I can see the details. And it's nice between the snapshots because, oops, I can take it back and forward, back, forward, and backward. Okay? If I take another snapshot, it will actually see how much megabytes, wait, maybe it's okay, how much my memory incremented. So it incremented 60 megabytes of memory that cannot release from the last snapshot and 40 megabytes again. So actually, I can look right now here in the allocation. I can see network state. And after I do a snapshot, I have an option to see only the live objects. So here I see all the objects that were allocating during the life cycle of the application. I can tell the profiler, just show me the ones that are still alive. And I do that, and I still see that I have 5 instances of my problem page. Of course, it's called problem page. So how do we solve this? What is the problem in this case? It's one of the simplest ones, because I am subscribing to an object that lives more than the page itself. Actually, it lives all the life cycle of the application. And when I subscribe, this object will have a reference to my page. So what I have to do in this case, who tells me what should I do? I have to unsubscribe. So the easiest thing to do is I'm going to use it on appearing, and I'm going to unsubscribe on disappearing. And this, I run again the profiler. And everything should be OK. So allocation, start profiling. I need the emulator, back and forward, back and forward. I increment 20 megabytes each time. And now I do a snapshot. And you'll see that the memory lowered. And not only I can do the filter, and I could say network state, only live objects, apply. I will do another garbage collector, and depending on some condition, it will clean up. But I don't have all the instances alive anymore, so I should apply. Sometimes it freezes, not my fault. But you can see we have solved that problem. Let's go forward, because there is a lot more. OK, so we will see an iOS one. And this is pretty simple to leak the way you will see right now. The advantage is sometimes Xamarin.forms solves this problem. So you don't have to be aware of this problem. So this sample is a reference count, cycle reference count. Cycle reference count, what does it mean? It means I have 2 user pairs. So I have 2 objects with state in .NET. So in order to keep them, the runtime, the root has a handle to them. And then the object have a reference to each other. So I have a parent view, OK, that adds a child view. And that child view, what it does, it has a reference to the parent, OK? And when I touch the child, it will change the background of the parent. And another way to debug memory leaks without the profiler, I can use override dispose. So if I override dispose, I can put a breakpoint. And if it's never hit when I do garbage collector, it means that that object is not freed from memory. So I have it here, and I have it here, breakpoints. So I'm going to run it. When you create a cycle reference, the garbage collector does not know how to break that, and it will leak that memory. So if you have 2 objects referencing each other, remember that you probably have a memory leak. So now I have in the main page a plus to add a custom parent that will add a custom child, an X button to remove them. So I will remove them. And then what delete does, it's running the garbage collector. So it forces, if I go into the view controller, you will see that it collects, it's waiting for the finalizer to finish and then collects again to be sure that I have cleaned all the objects. So what you will see here, if I hit the garbage collector, you will see that the dispose method was not hit in the debug. This means that I have a memory leak, right? So how do we solve this problem? As it's a circle reference count, the only way to solve it is to cut the connection between the parent and the child. You can do that when you unload it, if you want, okay? Or you can do that without using the using the super view. So when you add a child to a parent, you can always use this dot super view as custom parent. Okay? And in this case, I don't have to set it anymore. So I don't have a reference from one onto the other. But I could do it when you remove it from the subview. I just take it down. So you add it, you remove it, add, remove again. Of course, my breakpoint is not hit because the garbage collector did not start. The nursery is not full, and the operating system is not under memory pressure. On iOS, I can simulate memory pressure. So I go into the simulator, I do debug, and I execute simulate memory pressure. And if I simulate memory pressure, then the garbage collector will start, and I can see that I'm hitting the breakpoints. Okay, so this memory is freed. Okay? Let's go to the insidious one. And this is really something that you would not expect. If it was fully .managed, you'll not expect it. So what I have is a storyboard where I have a main page that navigates to a second page. And in the second page, I have a slider. And what I do is subscribe to the value changed of the slider and change one label on my window. And it uses the same method, so we don't have to use the profiler to see if it's leaking because I'm overriding dispose. And if I hit this, I know that this memory will be freed, so I don't have a leak. So I will just run it. Okay, so let me push it. I navigate to the second view. I have the slider. Okay, I navigate 2 or 3 times, and I force the garbage collector. And the dispose is not hit. Okay? You would expect it to be hit, right? I just subscribed value changed. But you have to understand what happened behind the scenes. So what happened behind the scenes is, as you subscribe value changed, you are giving state in the .NET world to the slider. So that slider, from a simple framework peer, is promoted to a user peer. Okay? So not only is promoted to a user peer, but as you subscribe it that, you are giving a reference to the method. So you are giving it a reference to the view controller. But the view controller already has a reference to the slider. So you have created a circular reference because the view controller has a reference to the slider, and the slider now has a reference to the view controller. As they both have now state in the .NET world, they also have handles from the garbage collector. So how do you solve this? But by not using lambdas. Sometimes it's in the Xamarin world, it's better not to use lambdas. Depends. So what you do is you have to subscribe and unsubscribe. So what you do here to just break it, so you create the event. Okay. And then you do override on view, view did unload, and you unsubscribe it. You run it again. Okay. Go again back and forward. Still haven't reached a condition for the garbage collector to run. We make it run, and it should work. It should work. Let me see. Plus, minus. Let me see. It's not override. You know what? I think it did not compile. So I forced to recompile it. Go back and forth. Now it's not hitting. Let me see. Who gives me the solution? So I will do another thing. Override view will disappear. Tick tock. And if it does not hit it anymore, okay. So now I unsubscribe it. I go again, unsubscribe the event, and do a garbage collector. And we hit the dispose. That's meaning that this view controller is being disposed. So it will hit it 2 times, of course. Interesting. And I have the last but not least, if the simulator moves from my way. Okay, so I hate it when it does this. So the last one, it's actually not a memory leak, but it will help you understand more how actually the native object is in the native part. So what I'm doing in this application, every time the user touches the screen and moves, I draw a line. We draw a line and we change the color of the line. So the way it works is I'm going to just run it and I draw it. But to be more interesting, I run it in the profiling, so you will see what happens to the memory. So I'm starting the profiler, still allocations, start profiling. Okay. My memory goes up a little bit. I am at 157. And I start to paint. So you'll see that right now I am 300 megabytes. But as I told you, it's not a memory leak. How do I know that it's not a memory leak? If I clean it, okay, the memory will be freed. So what happens here? So I'm going to draw some more. And I'm going to see how many here in the profiler. I'm going to see how many UI images I have. So I see UI image. And I have 165 images, OK? And the interesting part here to see, 165 get in the managed space 6.4 kilobyte. So average 40 bytes for each UI image. But then on the native part, it has like 254 megabytes occupied. Because this UI image, which is a proxy, keeps locked an UI image that it's the full image, the native one. So in this case, as I don't have a memory leak, you could say, I don't care. But you can improve this process because what happens here, just to show you a little bit. So it's drawing the image on the context. So I have an image draw image, which is the image that I'm drawing, and I'm drawing the image on the context. So here I am allocating an image, a new image, OK? But it's a cycle. So if you see here, draw line, it's called each time. So each time, when I don't need the image draw, actually, by initializing with another image, that memory will be freed. But when it will be freed? When the garbage collector starts. When does it start in this case? Probably with memory pressure, because I won't fill the nursery with 40 bytes elements easily. So in this case, what you do usually is what I told you. As the managed memory and the native one are together, I can use dispose to cut the connection, and then iOS runtime will free the native part. So in this case, I can say image draw dot image. If it's not null, call dispose. OK? And what you will see is that actually the memory stabilizes. So I start drawing. I'm at 157, and it remains there in the memory. Because by calling dispose, I forced the retained count on the native part on the image arrives at 0, and iOS frees the object right away. If it was Android, it will have to wait for a garbage collector from the Android garbage collector. So the pinpoints that I would like you to take from this presentation, of course, you can leak memory. Let me see, where is it? OK. Prefer full delegates over lambdas. It makes it easier to see and understand strong references. Especially for images, you should call dispose to release the native resource. Actually, when you call dispose, you cut the connection between the managed object and the native object. They both exist. And always unsubscribe from events you are subscribing. Xamarin Forms help you a little bit because it does this thing for you. So you don't have to unsubscribe them because they unsubscribe it in the renderer when it's not used anymore. And if possible, use the storyboards and connect the events. So use the actions instead of subscribing events, and use the delegates instead of subscribing the events. I hope you find it interesting. So if you have questions, I know it's the last session of the day, and you are tired, and everybody wants to go home.
So how good is the recycle setting for list views? Is it good about cleaning up?
Yeah.
If you're not doing anything like fancy, if you're just like
And here the questions goes in two sides, iOS and Android. iOS, it's really good because it frees the memory right away. On the Android part is as good as it gets because you have two garbage collectors. There are methods that you should incorporate as much as you can in each space. So if you can have a .NET object that is the list and everything and encapsulate that in the .NET space more, it will go faster. But it is OK. On the list view, you see it right away because the two garbage collector work a lot more. But
Is it image enough on the Android side to quit using FF image loading, or is it still better use FF image loading because it frees memory better than the Xamarin Forms image?
And it has a better management. On Android, probably you should use Jonathan Pepper's GlideX image because it's optimized on Android. But it's good. The FF image loading, it's really good.
I have a question back here, all the way back here standing up. So thank you very much for the talk. It's all the good stuff that we have learned today. My question is when deciding between the very basics of your programming style, right? For example, choosing a class over struct and a struct over class due to allocation, performance, speed, whatnot. What are your recommendations on when does it make sense to make an object a struct and get rid of it because it's a stack allocation versus making everything a class?
Good question. No, I think in the end, from the Xamarin point of view, it depends on, it depends. For example, what I'm saying, if you do it as struct, it will live only on the .NET side, and it will be fully managed. If you do it a class, it can be fully .NET managed, but you can derive from Android Java object. So you are creating a class that exists in both space. It has a part in the native one and a part that managed. So I think it depends on the situation when you use class or struct. It's a C# language decision, right? I would use class, but.
The last time I checked, Xamarin Profiler was like $300 a month for the enterprise license, something like that?
Yeah. Actually, we have to ask the Microsoft people to make it free for everybody because it's really important. No, because it's not that simple. Why it should be free? Because you actually inject a runtime, and it's not easy to see this. So you want quality apps, and when you say quality apps, you have to have a profiler for quality apps, and you have to give it to everybody. So I think the profiler is not as good to ask so many money for it, and it should be free for everybody. But I'm not making this decision. I think there are a lot of Microsoft people here, so you can ask them. I've tried to ask sometimes in our calls, and it's a commercial decision. But I think it should be free for everybody.
Question, do you have like a free version or some other versions other than the local ones that we can look at?
The other one, it's use override dispose, override write finalizer for the objects, or see in the debug how the stacks goes. But there is no free one, as much as I know.
What are the instruments in the Android profiler?
Yeah, you could use the Android profiler, the native one, and the instruments in Xcode. And you will understand that object, because you will see it in the native one also, leaks. Then you have to understand why it leaks.
Yeah, I tried the local one for iOS, and it would tell me like no stack trace. So it's useless to, like, it doesn't tell me where the memory is, so I can't do anything about it. So.
Yeah. Please.
Forms, there's no life cycle events like unload and load, and there's only the on appear and disappear. So like when we're navigating through complex like navigation stacks, when should we unload, when should we unsubscribe to those events?
No, actually, on Xamarin Form, it's the renderer that unsubscribes, so you shouldn't be preoccupied by this one. because you will have the object, which is the Xamarin Forms that can be collected, and then the renderer that unsubscribes from that event. Actually, if you are not subscribing to an object that lives more than your object, then you shouldn't be preoccupied about that stuff.
So I have a question, just to confirm, when should we use GC collect over dispose in terms of?
Usually you shouldn't use GC
shouldn't.
collect, okay? But when you know that you are using a lot of memory, so like images, you could force a GC collect to force the garbage collector on Android to collect what you've allocated. You can use it, and dispose on iOS works perfectly because as the other part works with automatic reference count, it frees the memory immediately. GC collect works good on Android because it will also force the Android to collect those. But if you don't do a large allocation on the native part, you shouldn't probably launch GC collect. Anybody else? I'm not so good at it. I would love to be good, but I'm using still the profiler. And how many of you do test for memory leaks in their Xamarin application? Nice. How many of you do have memory leaks? Oh, all the same. How many of you resolve those memory leaks? Okay. Okay, if you have any more questions, I'm here during the 2 days. Thank you so much. I hope you really enjoyed it. Thank you.